Ever wondered how medieval farmers fed entire cities without chemical sprays or any kind of fertilizer? Medieval farmers developed natural growing methods so effective they doubled crop yields while building soil health. Today, I'm sharing 12 educational farming secrets that sustained civilizations for over 1,000 years. Smart field rotation. Medieval farmers invented the three-field system that revolutionized agriculture across Europe. Instead of leaving half their land empty each year, like earlier methods, they divided farms into 3 sections. One planted with winter crops like wheat, one with spring crops like oats, and only 1/3 left fallow. This simple change allowed farmers to grow crops on 2/3 of their land instead of just half, effectively doubling their potential harvest without using any artificial fertilizers or chemicals. Magic. Bean power. Medieval farmers discovered that certain plants like peas, beans, and lentils had an amazing ability to improve soil naturally. These plants, called legumes, could capture nitrogen gas from the air and convert it into nutrients that other plants could use. When farmers planted beans in their spring fields, the bean roots would actually add nitrogen to the soil, making it more fertile for the next year's crops. This natural process worked better than many modern fertilizers because it provided steady, long-term soil improvement rather than quick chemical boosts that can damage soil over time. Animal partnership. Medieval farms operated as integrated systems, where animals and crops worked together in beneficial partnerships. Farmers didn't separate their livestock from their fields. Instead, they used animals as living fertilizer factories. Cows, sheep, pigs, and chickens would graze on crop stubble. After harvest, eating plant waste while depositing manure directly onto the soil, this manure provided essential nutrients for next year's crops, while the animals got free food from crop leftovers. The animals also helped with pest control by eating harmful insects and weeds. This partnership approach meant farmers didn't need to buy expensive fertilizers or pesticides because their animals provided both services naturally. Modern industrial agriculture has largely abandoned this integrated approach, but many sustainable farms are rediscovering the benefits of combining crops and livestock for healthier soil and better yields. Free grazing systems. Medieval farmers used their fallow fields as productive grazing areas rather than letting them sit completely unused. During the year when a field rested from crop production, farmers would turn their animals loose to graze on whatever weeds and wild plants grew there naturally. This served multiple purposes. The animals got free food, their hooves helped break up compacted soil, and their manure fertilized the field for future planting. The grazing also prevented weeds from going to seed and spreading to productive crop areas. This system meant that even empty fields were contributing to the farm's productivity. The animals would eat plants that might compete with crops, while simultaneously preparing the soil for better growing conditions. Modern farmers often spray herbicides on fallow land or leave it completely unused, missing the opportunity to gain natural fertilization and soil improvement that medieval farmers achieved through strategic grazing management. Natural soil building. Medieval farming communities developed sophisticated cover crop systems that eliminated the need for traditional fallow periods while continuously building soil fertility. Farmers would plant specific crops like vetch, clover, turnips, and other plants not for harvest, but specifically to improve the soil. These cover crops served multiple functions. Their roots prevented soil erosion during winter months. They suppressed weed growth, and when plowed back into the soil, they added organic matter that improved soil structure and nutrient content. Some cover crops, particularly clovers and vetches, were nitrogen-fixing plants that actually added fertility to the soil while growing. This meant farmers could use their land more intensively without depleting it. The Low Countries of the Netherlands and Belgium pioneered these techniques in the 14th and 15th centuries, achieving remarkable increases in agricultural productivity. Modern organic farming has rediscovered many of these cover cropping techniques, finding that they can be more effective than chemical fertilizers for long-term soil health and sustainable crop production. Waste into gold. Medieval farming communities developed comprehensive waste recycling systems that turned every type of organic material into valuable soil amendments. Nothing was wasted. Kitchen scraps, food waste, plant trimmings, fallen leaves, wood ash, and even human waste were all carefully collected and composted into rich fertilizer. Farmers understood that healthy soil needed diverse organic inputs, so they created systematic approaches to gathering and processing all available organic materials. Village communities often had designated areas where residents would deposit organic waste, which would then be distributed to local farms. Wood ash from fireplaces provided potassium, food scraps contributed nitrogen and other nutrients, and plant materials added carbon and organic matter that improved soil structure. Archaeological evidence shows that medieval farmers were incredibly efficient at recycling organic waste, with very little material ending up as true waste. This circular approach to nutrient management meant that communities could sustain productive agriculture for centuries without depleting their natural resources. Modern research has confirmed that these traditional composting and waste recycling methods can produce fertilizers as effective as synthetic alternatives, while building long-term soil health and reducing environmental impact. Perfect. Timing methods medieval? Farmers developed sophisticated understanding of seasonal timing that maximized natural growing conditions without requiring artificial inputs. They learned to work with natural weather patterns, planting winter crops like wheat and rye in autumn, when cooler temperatures and natural moisture provided ideal growing conditions. Spring crops like oats, barley, and legumes were planted when warming soil and increasing daylight hours supported rapid growth. This timing took advantage of natural soil cycles, as autumn planting allowed crops to establish root systems during mild weather and develop cold tolerance for winter survival. Spring planting coincided with natural soil warming and increased microbial activity that made nutrients more available to plants. Medieval farmers also understood the importance of harvest timing, knowing that crops gathered at peak ripeness provided better nutrition and storage life. They developed calendars based on local climate conditions rather than arbitrary dates, ensuring that planting and harvesting aligned with optimal natural conditions. This seasonal awareness meant that crops grew under ideal conditions with minimal stress, reducing the need for supplemental inputs like fertilizers or pesticides. Modern agriculture often fights against natural cycles by forcing crops to grow in inappropriate seasons, requiring expensive inputs to overcome natural limitations that medieval farmers simply avoided through better timing. Soil matching science. Medieval farmers developed remarkable expertise in matching specific crops to particular soil types, maximizing productivity by working with natural soil characteristics rather than trying to modify them artificially. Through generations of careful observation, they learned that different plants thrived in different soil conditions and developed regional specializations based on local soil types. On sandy soils, farmers primarily grew rye as a winter crop because it could tolerate the well-draining but less fertile conditions, while reserving wheat for richer, heavier soils that retained more moisture and nutrients. Clay soils were recognized as ideal for wheat production, while lighter soils worked better for spring crops like oats and barley. This knowledge extended beyond basic soil texture to include understanding of drainage patterns, natural fertility levels, and seasonal moisture retention. Medieval farmers could assess soil quality by observing natural vegetation, drainage characteristics, and even soil color and smell. They knew which areas of their farms were best suited for different crops and planned their rotations accordingly. This soil-specific approach meant that crops grew in conditions where they naturally performed best, reducing stress and the need for amendments or fertilizers. Modern soil science has confirmed the accuracy of many medieval observations about soil-crop relationships, and precision agriculture is rediscovering the benefits of matching crops to specific soil conditions rather than trying to force uniform growing conditions across diverse landscapes. Green plant fertilizer. Medieval farmers pioneered the practice of growing crops specifically to be plowed back into the soil as natural fertilizer, a technique called green manuring that modern organic agriculture has enthusiastically rediscovered. This method involved planting fast-growing crops like buckwheat, mustard, rye, or clover, specifically for the purpose of soil improvement rather than harvest. These green manure crops would be allowed to grow for several months, then cut and plowed directly into the soil while still green and full of nutrients. The decomposing plant material provided a rich source of organic matter that improved soil structure, water retention, and nutrient availability. Different green manure crops provided different benefits. Legumes like clover and vetch added nitrogen through their root nodules. Deep-rooted plants like turnips brought nutrients up from lower soil layers, and fast-growing crops like mustard helped suppress weeds while adding organic matter. Medieval farmers often used green manures as transition crops between main growing seasons, planting them after harvest and plowing them under before the next planting. This practice maintained soil fertility without the expense of purchased fertilizers and actually improved soil health over time rather than depleting it. Some regions developed sophisticated green manure rotations that included multiple different plants throughout the year, each contributing specific benefits to soil health. Modern research has shown that green manure crops can provide all the nitrogen needs of subsequent crops while improving soil biology, water retention, and overall ecosystem health. Water management wisdom. Medieval farmers developed sophisticated irrigation and drainage systems without modern machinery. They created terraced fields on hillsides to prevent erosion, built strategic ditches and channels to direct water flow, and used mill ponds that served dual purposes for grinding grain and managing water resources. They understood how to read landscape features to predict where water would naturally collect or drain and position their crops accordingly. Many also employed raised bed systems in wet areas and constructed ingenious water wheels and aqueducts to move water where needed. Whether reading and seasonal strategies before meteorology, medieval farmers became expert weather predictors through careful observation of natural signs. They watched cloud formations, wind patterns, animal behaviors, and plant responses to forecast weather changes days in advance. Red skies at dawn warned of storms, while certain bird migration patterns indicated harsh winters ahead. Farmers noticed how cattle gathered together before rain, how cats groomed themselves more vigorously before storms, and how flowers closed their petals when pressure dropped. They developed detailed seasonal calendars that coordinated planting, harvesting, and livestock management with lunar cycles and traditional weather patterns. These almanacs, passed down through generations, contained precise timing for every agricultural activity. They knew to plant beans after the last full moon of spring, harvest grains when morning dew patterns changed, and move livestock to sheltered pastures. Before winter's first signs appeared, this included knowing exactly when to plant different crops for optimal growth, when to harvest for best preservation, and how to prepare for seasonal challenges like late frosts or early winters. Farmers developed contingency plans for weather extremes, storing extra feed, preparing cold frames, and maintaining multiple planting schedules to hedge against crop failure. They also created microclimates, using strategic placement of buildings, walls, and trees to protect vulnerable crops. Stone walls absorbed heat during the day and radiated warmth at night, extending growing seasons. Windbreaks of carefully positioned trees protected delicate plants from harsh winds, while south-facing slopes were reserved for heat-loving crops. These techniques allowed farmers to grow crops beyond their natural climate zones. Moving farm strategies. Some medieval farming communities developed an innovative approach to soil fertility that involved periodically shifting the locations of both fields and settlements to take advantage of naturally enriched soil areas. This system, documented in various parts of Europe, recognized that areas around human settlements became highly fertile over time due to accumulated organic waste, composting materials, and general organic enrichment from human activities. Instead of trying to transport this fertility to distant fields, some communities would strategically relocate their farming areas to these naturally enriched zones while allowing previously farmed areas to rest and accumulate organic matter from new settlement activities. Archaeological evidence suggests that this rotation of settlement and field locations could maintain high agricultural productivity for centuries without soil depletion. The abandoned settlement areas would naturally accumulate organic matter from decomposing building materials, accumulated waste, and natural vegetation succession, creating highly fertile soil that could later be converted back to agricultural use. Meanwhile, the previously farmed areas would have time to restore their natural fertility through fallow periods and natural soil development processes. This approach required communities to maintain flexible land use patterns and avoid permanent, fixed settlements but it provided a sustainable way to maintain agricultural productivity without external inputs. Some regions of Europe show evidence of this settlement rotation pattern continuing for hundreds of years, suggesting it was an effective long-term strategy for maintaining soil fertility. Modern permaculture and sustainable agriculture movements have begun experimenting with similar approaches to land management that work with natural cycles of fertility and soil development, rather than fighting against them. These medieval farming methods demonstrate that sustainable agriculture provided abundant food for centuries, using only natural processes and careful observation of environmental patterns. Medieval farmers achieved remarkable productivity through understanding soil biology, plant relationships, and natural cycles, rather than relying on external inputs that modern agriculture depends upon. Their integrated systems built soil health over time while producing consistent yields that supported growing populations throughout Europe. These techniques succeeded because they worked with natural processes rather than attempting to override them with artificial solutions. Many of these methods are being rediscovered by modern sustainable agriculture as farmers seek alternatives to expensive chemical inputs that can damage long-term soil health. The medieval approach of combining crop rotation, animal integration, waste recycling, and careful timing created resilient farming systems that sustained communities for generations. Understanding these historical methods provides valuable insights for developing more sustainable modern agriculture that can feed growing populations while protecting environmental resources for future generations. Medieval farming wisdom offers practical solutions that remain relevant for contemporary agricultural challenges.